Hi guys, my name is Sanskar Shete, and here with me is Hemant BS. Uh, we are actually batchmates from MSc, and we both are into data science right now. He is a data science professional at a very well-known startup in Bangalore, and I'm working as a junior research fellow at IIT Roorkee. Uh, we both have a good amount of knowledge in data science, but he's into core data science, and I'm specifically into maybe agriculture or civil engineering or climate. So yeah, the major point and why we started this video, I think we can say podcast, is to
Yeah,
discuss about different sort of applications of data science, basically, right? So you know there will be some days which where he'll come up with uh, a new application or a new use case of different data science problems. So today, actually, I'll be starting with a project on prediction of winners in F1 races. So why I've selected this project, I think I'll be explaining in the video further. But why I've started, why I've selected this project is basically, I'm fond of F1 and I'm fond of machine learning. So, I thought, why shouldn't we join both of these things together? So, yeah, this is me. And I think, Hemant, could you just give two lines about yourself?
yeah. Hi everyone. I'm Hemant, and as I said, said by Sanskar, we both were batchmates and we both were roommates, and we had a lot of ideas to do. So we were thinking where to start, and I think this is the right time and the right idea to start with, and where he has expertise in image processing and other stuffs, and I have expertise and I'm doing work on forecasting and LLM things. So it's a right time and right opportunity I hope to share our knowledge and to grow together. And from today onwards, we will be starting the serious continuous discussions on data science and advanced data science concepts. So hope we are able to deliver the quality content and the quantity too in terms of numbers. So let's start with the today's discussions.
Sure. And, just a disclaimer, right? So both of us, we have mostly been backbenchers or, immersed into our studies, but this is the first time we are coming in front of cameras to share what we have. So obviously, uh, there's a 100% chance that there will be a lot of fumbling, there will be a lot of laughing, giggling, and if you see me smiling somewhere when Hemant is talking, you can understand that there's something going in my mind that he has done something. So yeah, this is just a very chill type of thing, and obviously, if we fumble, so we apologize for that beforehand. So yeah, as we go forward into this, so we just hope to get better and better, and yeah, yes, hopefully we get mature into this, right? So yeah,
Yeah,
so I think shall I get started?
yeah, sure.
Great.
Let's start.
So I'll
Yeah,
try sharing my screen once. Please tell me if it's visible.
yeah, sure.
Can you see my screen?
Yeah, it's visible, bro.
Oh, great. Oh, over here. Okay. So this is my actual script, the main script for our project today. What the main idea for this project is to predict the winner for the 2025 Australian Grand Prix. So how
Okay.
doing that is by taking the qualifying timings of 2025 and race timings of 2024 for the same track. Okay. Now, in the first
Yeah,
part of our script, we are actually installing and importing. all our dependencies, which include Fast F1. Fast F1 is an API which will be giving us data on everything, including weather, the weather condition, the tire condition, the lap speeds, braking, acceleration, throttle, n number of things. So this is what Fast F1 will be providing us. If you want to verify all this data, so I can say that this is our total. I can go over here, and yeah, this is the whole documentation of Fast F1 API. And right now, to validate this, I'll be sharing uh, the official F1 page and our results in the end.
Okay, sure. No
Yeah,
worries. Let's move ahead.
yeah. So we have important fast one F1 API. To install that, we have to do the basic pip install fast F1. Then with that, matplotlib and other libraries will also be imported. Next one is
Okay,
Panda.
sure.
The other one is NumPy. Uh, for the train test split, the basic machine learning requires one major library, which is scikit-learn. And scikit-learn holds all the uh, major functions which is required for different machine learning models. So uh, we can select our models which might be classifier or regressor. We can choose our train test split. We can choose our metrics and n number of things. So that is exactly
Okay.
what we're doing over here. Uh, Gradient boosting, as we know, gradient boosting is an enhancement of decision tree, which is an ensemble model. So that is what we are uploading here. Gradient boosting regressor is majorly used for many sports analytics related use cases, because
Okay.
it factors in different sort of uh, non-linearity in our model, in our data set, if it's structured or unstructured. So this is one major thing that helps us a lot. And obviously, since our data since we want to do prediction, so we will be using a regression function. uh,
Okay.
Here what we are doing is creating and enabling cache. So cache is
Okay.
anything that stores all our temporary files, which we might be reading in the future, or uh, which is created during our whole process. So I've created
Okay.
a cache over.
Uh,
Yeah.
okay. Before moving ahead, like I wanted to know what was the reason behind choosing this project, like
Oh,
choosing this data set. Yeah.
great question. So it's been around 4 to 5 years that I've been seeing and watching F1, and I'm watching it very closely. So, every
Yeah.
pre-practice session, or maybe the qualifiers, the main race. So testing also, there is a specific testing that is happening before every season. So that is where you get to
Mhm.
know about the car, how will be the car, how will the car will be performing in the coming season, and we get the first look in
Okay.
the car. So I'm actually very interested in these cars, and F1 is, one of the fastest. F1 cars are the fastest cars in the world, and yeah, that is one of the reasons why I got interested in F1. And after getting to know about the sport, how it works, so I thought, why not, try to create a model that will help us predict the winner for the upcoming season, and for the upcoming
Yeah.
race. So this was my main reason for starting off with this.
Okay. It's a great idea, bro. Like you're combining passion and the professional knowledge together
Yeah, yeah,
and
right.
doing something. Yeah.
Yes.
Yeah. Let's move ahead.
Okay. So yeah, I have created the cache in my main directory, which is de files demo, and my uh, yeah, demo is my main directory. Then what I'm doing here is I'm loading the data for the 2024 Australian GP. 2024 means the previous year, and I'll be
Okay.
taking uh, race timings for last year. So
Mm-hmm.
this line, it tells us, I will be storing the data in this variable named session underscore 2024, and this get session function accepts arguments which are 2024 means which year, 3
Okay.
means what number of race are you talking about, means Australian GP was held on number 3 in the last year, so it was the third race of our season, so that's why 3. And R means race, so I want the timings for the race of 2024 Australian GP. So these three things,
Okay.
if it specifies this. If you want timings for qualification, you can write Q. If you want timings for free practice, you can write FP. So yeah,
Okay.
yeah. Now after loading all this data in our variable, I will be extracting the lap timings. So obviously, as I've explained, that I want lap timings for every driver in the
Mm.
2024 Australian GP. So here I have
Mm-hmm.
taken driver and the lap timing. And there are actually a lot of things that I've said before, like the weather condition, the tire condition, the track conditions, temperature, and wind speed. So there are a lot of things, but here,
Okay.
uh, you know, uh, just for the simplicity of this model and for us to understand, I've used only two of them, which is
Okay.
name of the driver and the and his lap times. Acha, this is one more thing, that instead of lap timings in F1 are taken in minute, second, and milliseconds. So
Okay.
what we are doing is we are just adding, we are dividing the minute to seconds. So if it is 1 minute and 15 seconds, we are by default calculating into 75 seconds, which is 60 plus 50,
75 seconds.
right?
Yeah.
So this function is uh, what we'll be going forward with. Right here, we have the 2025 qualifying data. So there are two ways we can do this. Given the time that I
Yeah.
had done this previously, which was when the qualifying of 2025 Australian Grand Prix had finished. So at that time, the
Okay.
data had not been uploaded to our API. So
Okay.
I had seen the qualification and I had taken the times from there. So uh,
Okay. And one more thing.
yeah,
Sorry for disturbing. Like, there are very minute differences in the seconds, right?
yeah,
Like that, there are difference in the milliseconds, not in the
right.
seconds too.
No, no,
Yeah.
exactly. So this is what I've really liked about F1 is that only the difference of few milliseconds, hundredth of a second, person can be
Mm.
divided into positions, right? That is from first to second. So that
Yeah.
actually, while watching race and when I see these types of results, I
Okay.
really get an essence of time, of how important time is, and even if two people are struggling and doing their best to run, but there is only
Okay.
this minute differences in time that divide these two people. So yeah,
Yeah.
this is the main thing. So yeah, I've written this data. I've manually typed this data over here. Uh, if I try to do this right now, so this data is available in the Fast F1 API, and since I fetched the data for 2024 race season right over here, so I wouldn't have to
Okay.
the same over here. I just have to write the same code, but I just have to change this from 24 to 25. And
Okay.
since Australian GP was the first race of the season, I'll have to change this to 1. And
Okay.
over here, I'll be writing qualifying for Q. Right.
Okay. Got
Yeah.
it.
So I'll change it back. Now we have our database.
Mm.
Using Pandas, I've converted into a data frame for the qualifying of 2025. Now, since
Okay.
time uh, I had taken the full names of our drivers, and I
Mm.
had inputted their name. So I've put this into a single dictionary, and then I've divided it
Mm.
into different uh, classes like driver and then qualifying time. So over here,
Okay.
what I've done is our API, it fetches the names of the drivers in three-letter codes,
Hmm.
right? So if we
Hmm.
have Lando Norris, so NOR is the code given by F1 to Lando Norris, the driver, right?
Okay.
So our F1, our API takes data in this form only. So here, what I'm doing is I'm normalizing our data basically, right?
Okay.
If I if I hadn't done this before, if I'm doing this right now, so as I've said, I just have to convert it into qualifying 2025 fast F1 dot get session 2024
Hmm.
one and Q. That's the same thing, and this step would have been skipped. But just for the
Okay.
understanding basis, this is what I've done over here. Now, yeah, mapping the full names of the driver, and yeah, we'll go forward. Now, what we have to do over here is we have to merge our data, right? How we are going to
Yeah.
predict our winner for 2025 is using the, as I've specified before, is using the qualifying timings for 2025 and the race
Hmm.
timings for 2024. So we have the data for
Okay.
2024 and we have the data for
Hmm.
2025, right? That's all we need right
Yeah.
now. We have the
Yeah.
names of our drivers.
Yeah.
So obviously, what I've done is I've done this dot merge function of our libraries, and uh, I want the driver code to be merged for the driver and the lap
Hmm.
timings for 24 and on the lap on the qualifying timings of 25. That's it.
Okay. Okay.
If I go on and print our merge data, so we'll get the timings for all our drivers for the 24 and 25 season, right?
Yeah.
Yeah. One more thing actually, uh, F1 drivers have a normal F1 race. There are 20 people. Before there used to be 30 people, then they decreased it to 25, then 21. So right now there are 20 people on the grid. But over here I've
Hmm.
taken just here over here I've taken just 12 drivers. So why I've done this is because uh, around more than five people in the grid for this season are rookies. Rookies means the people who have entered new to the game. So
Okay.
obviously we won't be having the data for them, right? So
Hmm.
for if I have to do the next if I have to do the prediction for our next race, right? So from that time I'll
Yeah.
be able to get the data for all our previous players as all our new players as well. So that's why I've taken just 12
Hmm.
uh, uh, 12 drivers for now. Right. I have
Okay.
done
Got it.
over here how we are going to do merge and how we will be uh, what column of our merge data set we'll be using and will be giving for our split, right? So for the qualifying time of 25, I've given X, and for the lap time of 2024, I've given Y. And this is just a execution error. If if an error should come up, it should give
Yeah.
this error, right? So if
Okay.
if our data set doesn't have any drivers or the uh, uh, qualifying timings, so this
Okay.
value error should give us this message that no data available for training. Please check the qualifying timings and data. So
Oh,
this is
to
just,
bypass that.
yeah, to bypass it, right? Now, as I
Okay.
said, that we'll be using gradient boosting model. So yeah, this is it. Over here we are dividing our data set into training and testing uh,
Hmm.
using the train test split of sklearn. Test size
Okay.
basically gives us an idea of uh, how much percent of our data should be being dividing for testing. So an
Okay.
ideal division of data is 80-20 or 70-30. So means 80% of our
Okay.
data is used for training and 20% will be used for testing.
Hmm.
Okay.
Okay.
Now I'll put everything in all of this in our gradient boosting regressor function. An
Hmm.
estimator basically tells us the number of decision tree we want to be making. right? More the
Okay.
number of trees, the more complex it will be. Means the that many times it will be seeing the data, right? And it will be
Mm-hmm.
it will be predicting based on that. Uh,
Okay.
yeah. Next, I'll be telling.
One second.
Yeah,
Sorry to disturb you. Let me explain to my audience what gradient boosting is. Like, there
yeah,
are n number of models in machine learning, and in that one mm, strong model is decision tree. And for some cons that has, there are more advancement in the research that they have done, and one of that is gradient boosting. Like, there are many boosting techniques like ADA boost, XG boost, and gradient boost. Like, what these will do is, like, this will take the more samples from the errors, and it will train that model again and again. And if we go through these parameters like n underscore estimators, it is having 100 decision trees, and learning rate is 0.1. That means, like, the learning rate will be the 0.1 to reach the global minima, like, to minimize the errors in the gradient descent. And random state is 39. It will be taking the samples in the same way if we restart also. If we restart the kernel, it will take the same samples again and again, so there won't be any fluctuation in the results. So that's it. Like, you can
right.
move ahead.
It's a very great explanation of gradient boosting model. So yeah, the model dot fit is a very basic function. Now, what we'll be doing is, what we want to predict, right? So
Okay.
we'll be predicting the lap times. So I've given a variable to that, and how will we be predicting it is using the qualifying time. Qualifying time is
Okay.
2025 season. So
Mm-hmm.
I've to create a new column for it. So it will tell us that predicted lap times for this season. So yeah,
Okay.
now yeah, this is where the main thing comes, and it's a bit of fun thing. Is that after predicting the lap timings for the desired uh, driver, here what is happening is dot sort values. So you know, basically it specifies that the person who has set the fastest lap time, he'll be positioned on the top, which means first, and then second, then third, then fourth, and so on and so forth. So this is what is
Okay.
happening over here, and here we'll be printing our final predictions for the winner of the Australian GP. And right here
Okay.
is, we'll be evaluating our model on what basis.
Okay.
What we are using over here is mean absolute error. So if
Okay.
I'll just run this one, I'll just run this once, and after seeing this, I think you'll be able to explain to the people that what mean absolute error actually is, right?
Yeah. Yeah,
So,
sure.
right. So I'll just run this once. Yeah. So lovely. This is what we can see over here. I hope the results are visible, Hema.
Yeah. Yeah. Yeah, it's visible, bro.
Great. So this is what we run. This is what we ran over here, and you know this part it's fetching all the data which is required for the data for the race from the API. Right.
Mhm.
As I had told you before, right, what all are available over here. So we can get
Yeah.
session information, driver information, session status data that, was there any, hazard car, alerts that were, there might have been accidents. So were there
Okay.
yellow flags, red flags, black flags, and or session interruptions, something like that. Lap count means obviously
Okay.
number of laps, status data, timing data, timing application data. Then we have the data for the car, which includes the
Mm-hmm.
aerodynamics and everything.
Mm-hmm.
Uh,
Mm-hmm.
right, the weather data, we have position data. So yeah, everything. Oh, race control messages is also a very great part of this. For the people who
Okay.
don't see. F1. So there are these messages which is being transmitted from the race control to the team, and the team transmits it to their respective drivers. It
Okay.
might be regarding anything. If you are crossing, if you are crossing illegally, or if you have done anything wrong according to the rules. Okay,
Okay. So let me explain about mean absolute error. Like it is an metrics used for the models to find the accuracy, like how better the model is. Is it performing in the real time or not? Like there are multiple metrics that we use, like mean absolute error, root mean squared error, and mean absolute percentage error, R2 score. Apart from that, we have F1 score, accuracy, and precision and recall. Like here, what mean absolute error is saying is like it is saying the difference that average difference between the actual and the predicted. Like here we can see that we have predicted nearly 12, right? It is as calculating the average difference between the actual and the predicted one. So if we decrease the mean absolute error, it is the better model we are giving.
right,
So we have our main aim will be here to reduce the mean absolute error.
right.
Okay,
Okay.
I'm done
So
with. So
great.
you can move
It's a
ahead.
very nice explanation. And mean absolute error, Hemant, what is the range that we take for mean absolute error? Is there a certain range, or it
No,
depends
there are no.
on the problem?
It depends on the data. Yeah,
Oh,
it depends on the data. Like there are no such
ba-
ranges. Like
basically,
if I am dealing with the data, like with if I'm dealing with the data in lakhs, I
hmm,
can't give the models which is like one or two errors. Like it is deviating one in one value or two values.
hmm, hmm,
Like I have to say that it is value differing in thousand or it is differing in 10,000. So mean absolute error doesn't have any range. For that, we have one more new thing like mean absolute percentage error.
hmm,
Like how much percentage it is varying from the actual to predicted one.
right,
So in that case, we can use mean absolute percentage errors to deal with this.
right. Wow, that's great.
Yeah.
So I think if I make this statement, or I just confirm with you or cross check with you, lesser the mean absolute error, better the model.
Yeah.
Will this be a
Yeah. Better the
correct?
model. Yeah, it depends on the data. Like we can't say like if I have a data of in the range like 10,000, 20,000, and if I am giving the accuracy like mean absolute error is having around 100, 200, then it is a best model. In
Right,
this case, if we try to reduce the mean absolute error in like in milliseconds or in 1 second or 1.2 seconds in that range, then it is a better model. I think so because we are handling with the seconds, right? Which is
right.
a small
It's a very
metrics.
fine measurement, unit of measurement.
Yeah.
Right. So yeah, great. Acha, so I think 3.47 seconds of mean absolute error is decent for our first try, especially
Yeah.
for in such a situation that we are only taking the qualifying timings for the previous year, and the qualifying timings of our current year, and the race timings of last year. Right. If
Okay.
we input if we input more variables into this,
Mm.
so obviously, first of all, we'll have to change the model that we are using, and
Yeah.
the complexity in the model will increase for sure.
Yeah.
And based on the tuning of the model, so it might give us a difference in mean absolute error. So that is a whole
Yeah.
sort of trial and error sort of thing, right?
Mm. Yeah.
So yeah, this is where we are right now, and since
Mm.
now we are only predicting the winner, and we can see that Lando Norris is being seen on position one over here.
Mm.
And to
Mm.
cross-check this, right, we'll be going to our uh, F1 website, and
Okay.
put up Formula One Louis Vuitton Australia Grand Prix 2025 qualifying, right? So I think we've seen this
Yeah.
before. I've seen this before as well. Lando Norris had 1 minute 15 seconds in qualifying, and so on, right? If we
Okay.
go to race results,
Mm-hmm.
we can see that, yeah, Lando Norris, position one. Position one means
Mm.
obviously the winner.
Yeah.
Yeah. So I think our model has given us a very good, in sort of prediction of the result of for the race just by using two
Yeah.
variables. It has given us a very good result, and
Mm.
for to get an idea about the second, third, and fourth position, obviously we'll have to include n number of you know uh, variables into it, like
Mm-hmm.
how many people did their pit stop, what was their tire conditions, what was the rain over there, what were the tire temperature, or
Okay.
so n number of things. So according
Mm.
to that, if we wanted to just find the winner for the race, I think our model has worked very well. And
Yeah.
talk about the lap time of Lando Norris, which says 1 minute
Mm.
22 seconds. So I think he has set the fastest timing in the race. And to
Mm.
check that as well, we have come to the Wikipedia official Wikipedia page of Australian Grand Prix of 2025, and we can see that
Okay.
fastest lap was set by Lando Norris in the McLaren Mercedes, and the timing was 1 minute 22
One
seconds,
po-
167 milliseconds, which is
Okay.
near about the same.
Near up. Yeah.
Yeah,
That's good.
yes. So yeah, this is what our model is, and this is how we can uh, predict the winner of an F1 race just by using
Mm.
uh, two of the attributes. So
Yeah.
the previous year's
Yeah.
winner, previous year's timing, as well as the qualifying timings of this year. Now, I think today is Sunday, right? Today is Sunday,
Yeah.
2025, 15th June. So today as well, there is a race. There's a race on the Canadian circuit, and we
Mm.
have the qualifying data, right? So I think in the next few hours, if I just I'll get the data from the net, and I'll just put those data points over here. So I think we'll be able
Mm.
to get an idea about who will be winning today. So yeah, it's really pretty
Mm-hmm.
exciting, and uh, I'll obviously trying to input more and more variables so that
Mm-hmm.
it gets a bit more interesting, and there will be a much more accuracy in our model, and you know it's just for me, so I think I'll be able to understand how machine learning and prediction actually works, what sort of models can we use,
Yeah.
what are the variables that are actually needed. So yeah, if
Yeah.
we go ahead into this, so I think we'll be need to derive a classification matrix. So we'll be able to
Mm-hmm.
understand what are the variables which are uh, majorly affecting the other variables, and which is at the end resulting to a person to win. So more the number
Okay.
of variables, there are a lot of complexities that will be added in the front. So yeah, that was it
Mm-hmm.
from my side, I guess. Think if
Yeah.
it's anything you want to say
Yeah.
or ask for, I'm open to it.
Yeah. I have few suggestions before winding up this session.
Yeah.
Like it was a pretty well good project, and the suggestions what I have, right? Like we have used only two variables in this.
Mhm.
One was dependent, one was independent.
Mhm.
Instead of that, if we try utilizing multiple variables,
Right,
so it will be much more dynamic. So we can give better accuracy, I think so.
right,
And
right.
and in the model, we have hard coded the things like estimators. We have given 100 trays we have given.
Mhm.
Instead of that, we can tune it using Optuna, like which will automatically select it based on the data set.
Oh, right.
Yeah,
Mhm.
based on the data set, it automatically selects maximum split node and maximum number of samples in the leaf node, and
Mm.
what should be the minimum samples to split.
Right.
So like this.
Mm.
So it will avoid the overfitting everything. So we can add much more variables here.
Right.
And one more thing, like because F1 race is a manual game, and year on year the drivers get in their physical body also they get changes, like they can't their processing time also gets slows down, right?
Right.
And their health factor, everything. So
Right.
there will be data drift, like we are training for the data of 2024,
Mm.
and we are using that for 2025, right?
Right.
So we have the data of 2024.
Mm.
His performance might be good in 2024,
Mm.
but we don't know about 2025 how it will be.
Right.
So we can generalize the model, or
Right.
we can extract the rules from the models. Like we can extract the rules. If this is the guy, if this is the labs, this is the labs. The rules will be in that manner only, right? In the decision trees.
Right.
So we can implement reinforcement learning
Mhm.
so that that drift can be captured.
Right. Right.
According to that, it will retrain the model and we are going to give the prediction.
Right. And I think
So,
reinforcement learning is a very great sort of is a very great niche in machine learning because
yeah,
there are very rare places where reinforcement learning is used. Majorly, people use
yeah,
the same supervised and unsupervised, but obviously
yeah.
there should be some use cases where we have to use reinforcement learning, right? So I think one of the
Mm-hmm.
major examples for reinforcement learning is
Mm-hmm.
the Tesla car, right?
Yeah.
So yeah, those are the automated cars. So obviously,
Mm-hmm.
how they trained the model for uh, driving the car is obviously
Mm-hmm.
they are putting obstacles in between the cars, and they say that you shouldn't hit this obstacle. If you do, then it's a whole reward and uh, what do you call that? Uh,
Punishment.
Reward and punishment sort of thing, right? So if you do good, you'll get
Yeah.
it, and if you do bad, you'll
Yeah.
punishment. So it's
Yeah.
as good as training a kid, right? And
Hmm.
we are training him to how to learn this, how to do that. And I used to get hit a lot in my childhood days. So if I
Yeah.
do two into three, if I used to say 10, my father used to hit me a lot. And then I used to
Huh.
correct it. So yeah, that is what reinforcement learning is. And the more we try
Yeah.
to incorporate it into general problem statements, so
Yeah.
obviously it will be of great help.
Yeah. And not only in those robots and all those things we are not using, like we are using in chat GPTs too.
Hmm.
Like we
Right.
are using in large language models so that it will get trained automatically, like adapt to the user.
Right.
And right now we are doing multiple researches also, like we are using it in forecasting part. And you said like we are using it in decision trees also,
Mhm.
like to avoid the data drift. Like we deploy the model, right? Once we deploy the model, uh, the data gets changes dynamically because we are getting a huge number of data daily, regularly.
Right.
So yeah, like we have to handle that data drift. Like distribution of the data will change us as the time passes.
Right.
Like you said, like in F1 Rise, we are going to train the model on 2024, and in 2025 again there will be data drift.
Mm-hmm.
Like there will be changes in the behavior of the guy, changes
Right.
in the behavior of the car, everything, weather. So we have to take into consideration, right?
Sure. Sure.
So there we can use reinforcement learning, past histories we can take,
Right.
we can reward the models.
Mhm.
So this was my suggestion, and it was a pretty nice project. And
Yeah, just to for people to get started into, this is one of the projects that is there. I'm currently actually working on object detection on
mm,
satellite imagery. So
mm,
that in itself is a very big. Or I don't know if it's big or what, but uh, it's a bit of tedious process, right? So
okay.
if we talk about this, so I think it's a very good project for a person who wants to get started into data science, right?
Mm,
So if if he is a sports enthusiast, especially F1 like me, I think you
Mm-hmm.
have people who are doing sports analysis for the cricket as well. People are there for
Mm-hmm.
football, and there's a lot of sports. So yeah, if you are a person who is interested in sports, this is a very great point to go forward with. If you are a person who is from an agriculture background, so you can get all these data
Mm-hmm.
from maybe if you want to do market analysis, you can get the data from AgMarkNet. You can do a
Yeah.
forecasting sort of thing, or you can do mapping of the soil for India. Then, if you are a person who is interested in climate, you can get and download
Mm-hmm.
climate variables from satellites or weather stations on ground. So, the possibilities are endless. You just have to have that
Yeah.
domain knowledge and, just the drive to do something for it and that creative,
Mm.
you know, and there
Yeah.
is data available all over the net. There are very
Mm.
few places, obviously for work purposes, for professional purposes, those data sets are paid. But yeah, if you want to do something educational purpose just to study and all, there's a
Yeah.
lot of free data
Yeah.
available. So, just go ahead, get your hands dirty. And yeah,
Yeah. And one more thing I wanted to say, like, if
yeah,
you wanna, if you are enthusiast, if you are a data science enthusiast, and if you want to analyze something, and we will be uploading videos regularly.
yeah,
So you will get a brief knowledge, if not a complete knowledge, you will get a brief knowledge. So where you can start.
right.
So we have planned multiple videos together in the upcoming sessions too. We have very good projects we will be sharing soon.
Right.
So please keep us supporting at the same time. So
Yeah,
it will give us a motivation to do some new things.
I think in the future sessions, I have actually lined up an object detection project as well. So,
Yeah,
and that I'll be doing using uh, the data set is custom, but if we want to go ahead with the data set that YOLO is trained on, so YOLO is actually you look only once. So it's based
yeah,
on the convolutional neural networks (CNN), which is
yeah,
a deep learning
yeah.
architecture. So it's a very
Mm,
great, CNN itself is a very great model for object detection on especially
mm,
data. So step up from that is YOLO, and YOLO
mm,
is trained on Coco dataset, and those images are actually taken from the ground. So if you want to say
mm,
what you see from the ground, you take a picture from there and
mm,
you see that this is a building, this is a car, this is a cat, this is a dog. So what I do
mm,
actually is I have a satellite imagery, and I create my own data set and train it on
mm.
YOLO. So this is one of the things that I have planned for the uh,
Okay,
upcoming videos. Hemant will be
okay.
working and he'll be explaining a lot about LLMs and NLP and everything. I think I look up to you know uh, to get some knowledge about something because I get stuck a lot many times. So I think he's a very great sort of mentor for me as well and anyone who wants to get into data science. So yeah, there's a lot going to come forward, and hopefully there will be more people who will be joining us. Right? There are
Yeah,
many of our friends from our masters or uh, you know as we go ahead and
yeah,
connect. So we hope that those people also collaborate with us and
yeah.
they share their own experiences in data science, their own projects, and how to motivate new people to get into it.
Mm,
So yeah,
mm.
this is
Yeah.
the major plan is right now.
Sure. Like here we have the expert in image processing everything. Like I have very little knowledge to share about. Like I have very little knowledge in everything. So I think he has expertise in image processing where I have little experience in like forecasting and LLMs. That's it.
I will be modest.
And with,
I'm not an expert, bro. I've just done a couple of projects.
yeah,
Uh,
like yeah. in the future we will be expecting to collab with some other experts
Right.
we have
Yes.
in our network.
Right.
Yeah,
I think it's
sure.
a
I
good
hope,
point. End over here, right?
yeah, it's going to end. So let's wind up. Like, I hope you guys enjoyed it and you got something to learn.
Right.
So we will be uploading the regularly the videos. So
Yeah, I think it's a good point. Yes, he's getting a bit
okay,
shy right
it's
now.
time.
These are first times in front of cameras, right? So
Yeah,
obviously, I know that I've fumbled a lot during this whole session. So obviously, it's a whole trial and error sort of thing. So the more we do, the more we grow and
get
understand
expertise.
what's growing, right? So I know after we end this recording, we'll go back and see the video and we'll be cringing a lot. I'll be cringing on the points where I fumbled. He'll be cringing on the points where he fumbled, and we will be laughing on each other. But yeah, that is the point where we'll be learning. And yeah,
Yeah,
it's just upwards from here. Let's see where it goes. Yeah, it's an end of the
yeah,
begin. Sure.
yeah, sure.
Chalo, great. Hemant, it was great having this session with you, and hopefully we come up with something new in the next meeting. Right?
Yeah, sure.
Great. Chalo.
Yeah. Okay, sure.
Okay.
Then bye. Let's wind up this meeting.
Sure. Have a great day, everyone. Bye bye. Have a great day, Hemant.
But mm.